Welcome back. The objective of this video is to do some sample problems where we convert a polar equation to rectangular form. We'll do maybe 3 of those, and then we will take one and convert from rectangular to polar. It will be helpful to be familiar with the equations of circles and the studies of conic sections because, well, we're working with the polar plane, and that is a circular plane, and you'll see we've got equations of circles in some of these. So let's start off with sample A. We have r equals 4, and again, sometimes these are pretty hard to figure out, but if I were on the polar plane with an r equal to 4, well, that's going to cover every single theta. Every radius of 4 could go all the way around, and we could cover every single angle that has a radius of 4, and that's really what this is. So let's go ahead and solve this, and let's get this into rectangular form. So if we square both sides, we get r squared equals 16. And we know from our conversions that r squared is equal to x squared plus y squared. So we can say x squared plus y squared, here's our rectangular form, equals 16. And sure enough, that is a circle with the center at the origin at 0, 0 with a radius of 4. And so we have the same picture on our polar plane as we would on our rectangular coordinate plane. In example B, we have theta equals 2 pi over 3. So in our polar plane, we have a theta, the angle is 2 pi over 3, which lands us, over here somewhere. But now that's going to be, we're going to cover every single radius that has a theta of 2 pi over 3. So that's going to be, looks like it's going to be a line with a negative slope. So let's go ahead and see what that is. Our theta, we know theta is equal to y over x, and that is equal to the tangent of 2 pi over 3. Well, the tangent of 2 pi over 3, if we go to our unit circle, and we would see that y over x is equal to negative square root of 3 over 1. If we multiply both sides by x, we get y equals negative square root of 3x. We are in y equals mx plus b. That is an equation with a slope of negative square root of 3 and a y-intercept of 0. And that, since tangent is slope, sure enough, that is our final answer. We have a line that covers every theta of 2 pi over 3. Example C, again, we're converting from polar to rectangular, and we know r is equal to, well, let's do this. R equals 2 cosecant of theta. The cosecant is the reciprocal of sine, so that'd be 2 times 1 over the sine of theta. If I multiply both sides by sine of theta, we get r sine of theta equals 2. Well, don't we know that r sine of theta is y? So y equals 2. So the polar form is r 2 cosecant of theta, and our rectangular form is y equals 2. So on our coordinate plane xy, y is always 2. So that's a horizontal line on our coordinate plane. D is r equals 6 cosine of theta. This one's a little bit tougher. I can't do the reciprocal like I did in C. So let's go ahead and multiply both sides by r. So if I multiply the left side by r and the right side by r, I get r squared equals 6r cosine of theta. Well, r squared, that I can convert to x squared plus y squared. And r cosine of theta is x. So that's all equal to 6x. Well, this is a circle, x squared plus y squared equals 6x. So let's go ahead and subtract 6x from both sides. And we get x squared minus 6x plus y squared equals 0, because I subtracted 6x from both sides. Well, back from our studies of conic sections, we can complete the square, or CTS, or complete the square for this. So we'll do x squared minus 6x plus some blank, and it's important to put that blank there, plus y squared equals, I don't know why I said 0 and I wrote 1, equals 0, plus, and when we complete the square, we're going to manufacture a number here next to the 6x, so we have to add it to the other side. So completing the square, we take half of our b value, so half of negative 6. So that's negative 6 over 2, and we're going to square it. Okay, well, negative 6 over 2 is just negative 3 squared is positive 9. So I've manufactured 9 on the right. I'm also have to add 9 to the left-hand side. Or I manufactured 9 on the left, so I have to add it to the right. Got my lefts and rights mixed up. Well, this now is a perfect square trinomial, because that's what we do when we complete the square. We complete the perfect square trinomial. So we get x minus 3 quantity squared. So if I took this and foiled it or did my pattern, I'd get x squared minus 6x plus 9 plus y squared equals 9. So now I have a circle with a radius of 3 that is centered at 3, 0. So if I go over to 3 on my x-axis, that's my center. So I've got a radius of 3. So 3 up, 3 down, 3 right, 3 left. So that I have a circle that looks like something like that. And it's centered at 3, 0. In example 7, now we're going to convert this to polar form. We have another circle that has a center at 3, 2. So we have a center at 3, 2, and a radius of the square root of 13. So here might be our center at 3, 2, and the square root of 13 is about 3.5-ish. So I go about 3.5 inches, to the right, above, below, to the left, and now I have a circle with a radius of the square root of 13 that's centered at 3, 2. But now we want to convert this to polar form. So this is going to be a little bit tougher. Hopefully your algebra skills are good. I'm going to FOIL all this out. X minus 3 quantity squared is just x squared minus 6x plus 9 plus, and then y minus 2 squared is y squared minus 4y plus 4, and that equals 13. I'm going to subtract 13 from both sides. So that's going to get rid of the 9 and the 4, and I get x squared minus 6x plus y squared minus 4y equals 0. I'm going to combine my x squareds and y squared, so I have x squared plus y squared minus 6x minus 4y equals 0. And now I can do some converting. Down here in the lower right, you can see I have my rectangular and polars. So x squared plus y squared equals r squared. So I'm going to take this x squared plus y squared and I'm going to convert that to r squared. and my x is equal to r cosine of theta, so I have minus 6 r cosine of theta, and y is r sine of theta, so minus 4 r sine of theta. I'm fairly close to being finished here. I do have a common factor of r in here, so I've got a GCF, so I'm going to take that guy out, and I get r times r minus 6 cosine of theta minus 4 sine of theta, and all that's equal to 0. Set each of the factors equal to 0, so I get r equals 0, which it can't. R can't equal 0 because that's the pole. So it'll just be a dot. And then we have r minus 6 cosine of theta minus 4 sine of theta. Set that factor equal to 0. Add all this to the other side to isolate r. So we get r equals positive cosine of theta plus 4 sine of theta. So I just moved all this over to the other side of the equal sign, and that is our final answer. So we have converted this circle into polar form. Oops, polar form. And we'll get some more practice with converting from polar to rectangular and rectangular to polar when I see you in class.